Remember, we were looking at solving radical equations. And when we solve a radical equation, we must check the solutions. Why? Because the principle of raising both sides to a power may create extraneous solutions. Excellent. So we only did one problem. I don't remember which one, but I would like to move on to problem 10. And then I'll let you choose. Allow me to look at a few problems and then you choose. The square root of 3x plus 3 minus 4 equals 8. Now, the first thing that I have to make sure in any time I solve, what type of equation is this, first of all? It's a radical equation, of course. This is a radical equation. So the first thing I have to do is isolate the radical, always. In order to isolate the radical, what should I do? Add 4 to both sides. So then I have the square root of 3x plus 3 equals 12. Now the idea is to remove the radical. I will have to square. How come that I don't cube? What is the power on 3x plus 3? 1/2. And this is the power we want to eliminate. In order to eliminate power 1/2, I have to square both sides. Good. What do I get on the left-hand side? Indeed. What do I get on the right-hand side? Very good. Now this becomes what type of equation, which I know how to solve? It becomes linear. So we know how to solve linear equations from a long time ago. So what will I do? Subtract 3 and end up by, so 3x equals 141. So x equals 47 indeed. Now it comes with a big question mark. What is that question mark for? I have to check, and I have to check back in the original problem. This is the original problem. This is where I plug in 47, right here. This is 47. So 3 times 47 is 141. 141 plus 3 is 44. The square root of 144 is 12. Is 12 minus 4 8? Only then I say yes. This is indeed the solution.
How do you get it in the first parentheses? This is square root of 3x plus 3, and then you said you multiplied by 2, but you still have 3x plus 3.
No, I said I multiplied this. So the square root of 3x plus 3 is the same with 3x plus 3 to 1/2. And I was asking, how come that we don't cube? And the answer is because if I want to cube this, the power will stay 3/2. But if I square this, the power will go away. So the square root of 3x plus 3 squared is 3x plus 3. Last time we discussed the fact that the square root of 2 times the square root of 2 is the square root of 4, which is 2. And if you remember, I deleted this and I said we should remember this from now on. So therefore, the square root of 3x plus 3 multiplied by the square root of 3x plus 3 is 3x plus 3 according to this. 1 second. Is this okay? Yes, please.
Just because we did that thing last time where we wrote I checked, do you recommend writing that for this, or is the yes and no?
You mean writing the intermediate step here, this one?
No, remember when we put the box around it and said I checked?
Oh yeah.
Do that for this, or is it
Yes, you have to just write that you checked or you said yes, or at least just show me yes. Indicate somehow that I know that you checked. Because if it's not the correct solution, then I will not be able to give full credit. Is this better? All steps? Other questions here? Okay. Plenty. Yes. So in problem 12, we have the cube root of 4x equals -2. How do I eliminate the cube root? And what power is that? It's power 1/3. So what should I do to both sides? Very good. So the left-hand side is? The right-hand side is? So from here, x is Good. It comes with a big question mark, but I will let you in a secret. If you raise both sides to an odd power, all solutions will work. But you still have to make sure that you don't have a mistake, or to be on the safe side, always go back. So this is the cube root of 4 times negative 2. Does this equal negative 2? So when the power is odd, that you raise both sides, or the index is odd, the answer should always work, unless there is an error somewhere. Very good. Let's move on to number 18. I claim that number 18 is more complicated than the previous problems. Can anyone look at this and say, I think you're referring to... Exactly, yes. The previous situations did not have any terms with x. The previous situations that just had radicals and some free terms, free of radicals, just constants. Okay, remember the key is to do what first? Right, I have to isolate the radical. So I will move 2x, so I have the square root of x plus 1 equals 8 minus 2x. Now there is a note here that I would like to put in. Never square term by term. Never square term by term. So here's an example, so if you'd like to pay attention for a moment, is 2 plus 3, 5. But if you do this, this will be a terrible mistake, because 4 plus 9 does not equal 25. So what I'm saying is, squaring not term by term, is this still correct? Yes. I can square the left-hand side and I can square the right-hand side as one unit. This is what I need to do. So coming back to our problem, I have to indeed take both sides to which power? Yes, square both sides. But be very careful, how many terms will you get on the right-hand side? Remember, we have a contract.
2.
No, not 2 and not 4. Yes, 3. So the left-hand side will be? Now the right-hand side, please remember that tune. First term squared minus 2 times the first times the second plus the second term squared. If you want to foil it, foil it. I refuse to foil it. You give me the answer, I'll put it in. But if you want to foil it, I'm fine. I personally don't want to foil it because when we factor, we always...
Oh, the 64 plus 4x.
No, it's not two terms. So we have a contract on a minus b everything squared that says it's a squared minus 2ab plus b squared.
So 64 minus 16x.
So 2 times 2 is 4. 2 from the formula times 2 is 4 times 8, 32x plus 4x squared. If you don't want to use the formula, I'm fine. Just foil it and get the answer. That's fine too. Okay, so now what type of equation is this? It's not linear. This was linear. It is quadratic. Very good. So how do I solve a quadratic equation? Say it again. I cannot isolate the x's because that's in a linear equation. In a quadratic, I have to
Get the power.
I have to set it equal to 0 first, and then we'll see. Okay, so then I have 4x squared. I subtract x from both sides, so it's minus 33x. And I subtract 1 from both sides, which is positive 63. Now, in the next chapter, we will review the quadratic formula. I don't like these numbers that are so big. when I have to factor, but since we don't know the quadratic formula yet, we will have to factor for now. Yes? You can use it if you want to, but I still have to use or show the factoring method. Yeah. So the product is 4 times 63. You don't have to multiply it. I wouldn't. The sum of the numbers I need to determine is negative 33. So 4 is 2 times 2, and 63 is 7 times 9, which is 3 and 3 and 7. So then I need to find two numbers whose product is this, and the same numbers whose sum is this. If the product of two numbers is a positive number, what type of numbers can I have?
Two negatives or two positives.
Right, but since their sum is negative, what type of numbers am I looking for?
Negative and positive.
One more time. If the product is positive, what type of numbers can I have? Either two negatives or two
Oh, you
positives.
want two negatives.
But their sum is negative. So there is only one option then.
Two negatives.
Two negatives. Excellent.
Sorry.
No problem. So now I need to find two numbers that add up to 33, but I have to use everything here. Just come up with two numbers. And when I add them up, I get 33. So one option would be, and I already see what, this is 4 times 3, right? So that's 12, and that's 21. That's what I need, 12 and 21. When I add them up, of course they have to be both negative, but when I add them up, I get negative 33. So then 12 and 21. What I need to do next is go back to the equation and replace. So I'm copying the equation. You don't have to copy it one more time. I need to. So I'm going to copy 4x squared, but instead of negative 33x, I'm going to write negative 21x and negative 12x. So negative 12x minus 21x plus 63 equals 0. And you can say, what did you accomplish? A lot. I split 3 terms into 4 terms because now I will factor by grouping. What would you factor out from the first two?
4x.
4x. What is left in parentheses?
X minus 3.
So it is x minus 3. What should I have coming out from the other two? Otherwise, I cannot continue.
X minus 3.
Now, only now I look. I need the sign and the factor in front.
Yes.
So 7 and the sign?
Nine.
Yes. Negative 7 times x is negative 21x. Negative 7 times negative 3 is positive 63. So this has to be the same. If it's not, I can continue. So don't try to look and then factor, because you may write something else. And now the common factor is x minus 3, and I get 4x minus 7. Now, we haven't finished, I know. Yes, so x equals 3, or x equals,
Positive 7.
so I move 7, I have to divide by 4. 7/4. Okay, we haven't finished still. But I just want to come back to the original problem and just show you how many steps this problem has. A lot. So first of all, although we didn't even finish it yet. So this is a radical equation. I had to isolate the radical. I had to move 2x to the other side. I had to square both sides as a unit, not term by term. That would have been nice and easy, but I can't do that. I square the left-hand side, and I get x plus 1. Now, when I square binomial, I cannot make that mistake and write 2 or 4 terms, right? I have to write 3. One more time. First term squared minus 2 from the formula times 2, which is 4. 4 times 8, which is 32x, plus the second term squared, which is 4x squared. You can still FOIL it, as I said. Now, because this becomes a quadratic equation, I had to set it equal to 0. I put it in descending order, 4x squared. I subtracted an x, and I get negative 33x. I subtracted 1, I got 63. Now I struggle factoring because the numbers are so big. So the product, because this is not 1, the product of the numbers I need is the product of these two, the leading coefficient and the last coefficient. Now, the sum is always the same, even if this is 1 or any other number. So the sum is negative 33. So what I did here was, instead of thinking of this product, I just wrote it in prime numbers. Instead of 4, I wrote 2 and 2. Instead of 9 times 7, because this is 9 times 7, I wrote 3, 3, and 7. It is easier, in my opinion, again, to see the prime factorization, and at that moment it was quite simple to come up with those two numbers. This number, which is 12, and this number, which is 21. Their product, I guarantee you, is this, because you use them all. Their sum, I guarantee you, is negative 33, because they both have to be negative. Negative 21 and negative 12. Any questions so far? So then we split up negative 33x into these two terms, negative 12x and negative 21x. So we factored out a 4x, and we got x minus 3. I did not look at the other two. I copied x minus 3, and then I realized that I have a factor of negative 7. So then I copied x minus 3, or pulled it in front, and then I'm left with 4x minus 7. And that's how we get x equals 3 and x equals 7 fourth. Just me reading the problem, it took me 5 minutes. So these are complex problems. Remember, what did I say about this topic in 10.6? Is one out of 2 most difficult topics, according to my experience, from this course. This is one of them. It takes you throughout the entire course. Look at how many steps. And I haven't finished. What do I have to do now? Plug it back in the original problem. I don't even remember what the original problem was. Here it is. Any questions?
I have a question.
Yes.
When you factor out the negative 7,
Yes.
wouldn't that be positive 7x?
To factor out from these two?
No, I'm saying, like, just look, if you pull out that negative 7, wouldn't that leave you with 3x minus 9?
Negative 7 times. Oh, I'm sorry. So it's 21. I didn't even look.
Okay.
I waited for you to say something, and I just wrote it down. I'm sorry. I'm sorry. It has to be x minus 3. It's mandatory.
Right.
Thank you. Thank you. No, somebody said 7. I didn't even check. I just wrote it down. I'm sorry. I apologize. My mistake. Sorry about that. It's okay. It's okay. But thank you for noticing it. So yes. So I have to factor out negative 21 one more time. Negative 21 times x is negative 21x, and negative 21 times negative 3 is 63. Thank you. So therefore, x minus 3 is out, and then 4x minus 21. So these are the two possible solutions. We don't know yet. Very good. So I replace 3, x by 3. So this is 6 plus 3 plus 2 is 4. The square root of 4 is 2 equals 8. I'll say yes. Now I have to replace, oops, nobody can see. Sorry about that. Now I have to replace x by 21 over 4. So here, 2 times 21 over 4 plus the square root of 21 over 4 plus 1. The question is, I don't know if that equals 8 or not. So I will simplify. So I have 21 over 2 plus. Here I have to find the least common denominator, which is 4. Very good. So then this one needs a 4. So then 21 plus 4. So now I copy 21 over 2 plus. How much is 21 plus 4? How much is the square root of 25? How much is the square root of 4? Because remember, the square root of 25 over 4, as we learned in this chapter, is this, which is 5 over 2. So how much is 21 plus 5? 26. How much is 26 divided by 2? Does 13 equal 8? So what will I say about this? No. We will not remember these steps if we don't practice with 20 problems at least. Because you will not remember. It's so much. It's so much. Okay, please choose the next problem. Yes, 22. Is it a homework problem?
I don't think so.
Okay. This is the most difficult type of problem. Okay, I will not test you on a problem like this, but I want you to see at least one. Why do you think I say it's difficult?
Too radical.
Exactly. It makes it very difficult. Yes. Now, I shouldn't say very difficult, but definitely cumbersome. Okay. It is wise to separate the radicals. In other words, if two radicals are on one side, it is wise to move one to the other. What happens if I have 3? You're not going to see an equation with 3 in this course. But if you have 3, you cannot do anything else but have 2 on one side and 1 on the other. Okay? But in this case, since there are only 2 radicals, I'm going to move this radical to the right. So the square root of 2x minus 4 equals 2 plus the square root of 3x plus 4. Now I have to do what? Square both sides. Oh, did I copy it incorrectly? Oh, thank you very much. Yes, I did copy it incorrectly. It is a -2. Thank you. Sorry, my mistake. Careful, there was a -2 in here. Okay. So when I square the left-hand side, what do I get? When I square the right-hand side, is a mess. But we did this last time. If you want foil, you can foil. You can write it on a piece of paper and foil it. So what do I write? First term squared. How much? Minus 2 times 2 times the square root. For the square root, indeed. Plus the second term squared. Note, when we solve a radical equation with 2 radicals, can I get rid of both radicals in one step? No, I must square twice down the road. So let's write that note. When solving a radical equation with 2 radicals, we must square twice in order to get rid of both radicals. So when solving a radical equation with 2 radicals, we must square twice in order to get rid of both radicals. So I have this step now. What do you think I need to do with this? Now it becomes a radical equation with 1 radical. So what did we do when we solved a radical equation with 1 radical? What was the first thought? Excellent. Yes, I have to isolate the radical, because otherwise I cannot square. So this has to go, this term has to go, and this term has to go. I have 2x on the left-hand side, but I'm bringing a -3x. I'm bringing a -3x. What do I have? Perfect. I have a negative 4, but I'm bringing another negative 8. The 4 plus 4 is 8. So I have a negative 4, and I'm bringing over a negative 8. Negative 12. Although we managed to clean it up a little bit, it's still awful. Okay. Now I see 3 terms that are negative. I want to get rid of that. Too many negatives. So what should I do to both sides to get rid of the negative sign? Divide or multiply by negative 1. So negative x times negative 1 is negative 12 times negative 1 is negative 4 times the square root times negative 1 is okay. What now? Yeah. I have to be careful with, bless you, with the left-hand side. How many terms will you give?
Yes. 3.
Yes, please. First term squared plus 2 times 12 times x plus 12. Very good. Now be very careful because the right-hand side has a product. I have to square the number in front first. And in parentheses, what do I have? Very good. Thank you. Okay. It's far from being done. So this is 6, 7. Okay. What now? So I have x squared plus 24x plus 144. And then? Very good. So 48x plus 64. What now? What type of equation is this? Quadratic, which means, so I have x squared, bless you, plus 24, but I'm bringing a negative 48, negative 24x. I have 144, but I'm bringing a negative 64. Very good. Okay, now this is a little bit easier than the previous one because now the product is 80. I don't have a number in front here, it's just 1. And the sum has to be negative 24. I look at 80, still a big number. I have 8 and 10. So this is 2, 2, 2, and this is 2 and 5. I'm going back to the prime factorization of 80. So 2 times 2 times 2 times 2 and times 5. One more time. Since the product is positive, what type of numbers do we expect to get? Yes, either 2 positive or 2 negatives, but since the sum is negative, then 2 negatives. So from here, please come up with 2 numbers that will give us 2 numbers multiplied, or in this case added, will give us 24.
We have 4.
4 and? Exactly. 4 and 20. So then, since there is the leading coefficient is 1, I can go ahead directly and factor. How will I factor?
X squared plus
X minus,
4.
yes? Good. You can always check. X times x is x squared. Negative 20x minus 4x is negative 24x, and negative 4 times negative 20 is positive 80. So what are the options then, according to this? But we have no idea whether they work or not. That's the type of problem that you will not see in 141. You will only see in 151. So I'm not going to test you on radical equations with 2 radicals unless it's a extra credit problem if you want to work on it or not. Okay, I go back a page later. I have the square root of 2x minus 4 minus the square root of 3x plus 4, and that's negative 2. So first I replace 4, x by 4. So 2 times 4 is 8 minus 4 is 4. The square root of 4 is 2. So this is 12 plus 4, which is 16. The square root of 16 is 4. Does this equal negative 2? If it's yes, then I'll... Good. So I'll say yes. And now I plug in 20. Here it is. So 2 times 20 is 40. 40 minus 4 is 36. The square root of 36 is 6. 20 times 3 is 60. 60 plus 4 is 64. The square root of 64 is... Does this equal negative 2? If it's yes, then I'll have to accept the second solution as well. It's a yes? Good. So it happens that this equation had 2 solutions. Any questions? Any questions? I would like you to work on 39. In 39, x minus the square root of 1 minus x equals negative 5. Now, John, which problem did you have in mind when we started today? You said one problem. I don't remember. Okay, is that okay now? Better? Okay. Yes. Okay, very good. Good luck. Have a safe return. I'll see you on Monday. Remember, the test is on Monday, next week. Can anyone get us started? Because I would like to suggest something. It's a very good idea. That's what I have to do. But because this is negative and this is negative, I would rather personally do this. And that will eliminate all negatives. So I'll say x plus 5 equals the square root of 1 minus x. You don't have to do that. But you will work a little bit harder with negatives in there. But it's fine. You'll get the same answer like I would if I use this method. Can anyone give us step 2? So we are all on the same. Very good. So what would you write?
X squared plus 4 plus 5.
Very good.
Would be the same way if you didn't do it that way.
Oh, of course. You'll get the same answer. Do we all understand this second step? Now is the time to say yes or no. If you have any questions, please. Okay, perfect. So what type of equation is this?
Wait a second. Where did you? Sorry, this.
Say it again.
I don't even know how to explain that.
I'll be ready when you are ready to ask.
This is kind of a dumb question, but I know you get 3 terms out of 2, but like, is that foiling thing? I never really get the foiling thing. I thought I did the box method thing, so
Use the
foiling, I
box-
don't understand.
But use the box method. That's fine. I'm super happy with any method. I'm not here to change what you know. I'm
But
here
when
to
I'm
show.
asking, how is it that you foil? You go, the square goes to x and goes to 5, but then where does it go?
So why don't you use the box method? Show me the box method.
Well, I don't even know how you would do. I haven't done that in like 2 years. I don't
Okay.
know what-
So in that case, allow me to explain how to square binomial. Okay. A plus b, everything squared, is a squared plus 2ab plus b squared. This is this. This is 5. When I square x, I get x squared. Plus 2 times 5 times x. 2 times 5 times x is positive 10x plus the second term squared.
I never wrote that down.
Okay, so then from here, what will you write? What will be the next step, please?
Oh, you have once 11 terms.
Very good. Excellent. These numbers are decent. They're not 80 or hundreds. Very good. I agree with x plus 3 and x plus 8. So it appears that the equation has 2 possibilities. What are they? Any questions till this step?
How? Yeah. How do you get to a negative now?
What negative?
This is x plus 3 and x plus 8 makes that x equals negative, so x equals negative.
Right. So if a product of 2 factors is 0, either a can be 0 or b can be 0. This is my first factor. X plus 3 is 0. I have to move 3 to the other side and I get x equals negative 3. Okay, so potentially this equation has 2 solutions. I have to go back to the original problem, which is x plus 5 equals the square root of 1. No, this is not the original problem. X minus the square root of 1 minus x equals negative 5 is the original problem. I am checking negative 3 first. Inside the radical, 1 minus negative 3. 4. Let's go to 4. 2. So is negative 3 minus 2, does this equal negative 5? So I will have to say yes. Now I will check negative 8. 1 minus negative 8. 9. The square root of 9. I have negative 8 minus 3. Does this equal negative 5? No. So I cannot accept x equals negative 8, and that is called the extraneous solution of the equation.
Why did you not have to do that thing? You split it off.
Because the leading coefficient was 1. When the leading coefficient is 1, there is no need to work that hard. Okay, I know I'm going to ask if we need more radical equation, and I know the answer should be yes, because this is not enough. We had like 5 examples, 6 examples, and I know it's not enough. But I like to finish this and then come back to more equations if you want on Wednesday. But if you say, I want another example now, please choose. If you have anything that you want to work on right now, please choose.
Other than this?
I'm sorry?
You need other than this?
Any equation that is a radical equation that you would like to work on right now.
We need 42.
Let's do 42.
I think it's easy, but I just.
Very good, let's do it. The cube root of negative 4x minus 3 equals the cube root of negative x minus 15. It's completely cleaned up. There is no attachments. The radicals are 2, but they are splitted, one on one side and one on the other. I'm ready to do what? Right, because we want to eliminate power 1/3 with the cube. Yes. The left-hand side. Very good. The right-hand side. I cannot change the signs inside. It's okay. So now this is really what type of equation? Linear. So if it's linear, all we have to do is move terms around. So I'm going to move this term here and this term here. After I do that, what do I write? Yes. Equals. Very good. -12. So it appears that x equals. Nobody knows though. We do, because we raised it to which power? To an odd power. This should work mandatory. So I'll go back. The cube root of -4x minus 3 and the cube root of -x minus 15. I will plug in +4 and see what happens. -4 times 4 is -16, minus 3 is -19. So the cube root of -19, does this equal -4 minus 15, which is the cube root of -19? So I'll say yes. But remember the little hint that I gave you? Every time you raise both sides to an odd power, the answer, the solution, the prospect solution should work. Okay. Do you think we need anything else from 1 through 50 at this point? Anything from 1 through 50 at this point?
We do one that is like 39.
Okay, let's work on 39.
No, it just
We just did 39,
that's the
yes.
one, like 39.
I don't know.
You could just make one up if you wanted to.
Oh, it's very hard to make one up.
Oh, okay.
Because, especially, no, the reason is because he may or may not have solutions that are integers. I have to work on it. I
Can we
can,
do, number 40?
okay. So x minus the square root of x minus 2 equals 4. So let's work on this for 1 minute, 2 minutes. Can anyone give us this first step, just the very first step, so we know that everyone is on the right track?
The X to over.
I would have done this. Yes.
Yeah.
Because I may forget that sign in front of the square root, although when I square it will disappear anyway. But I recommend this. You will get the same answer, of course. Then what will be the next step?
You square. Oh, you do both sides.
I have to do both sides. It's like adding 5 to both sides, or subtracting 5x from both sides, or multiplying both sides by 3. It has to be both sides. Because, see, if I say to you x equals 2, and I say, oh, well, let me just square the left-hand side. That'll make no sense. Right? Because if x is 2, 4 is not 2. But this will be correct. So I have to square both sides, or cube both sides. Although this is not a basic principle of equations, which means I may or may not get solutions that work. Okay, so then the left-hand side, minus,
See, now that's the part that I guess
right. First term squared minus 2 times the first times the second, plus the second term squared, and I get x minus 2. It's the same formula, but with minus.
For both sides?
I'm squaring the left-hand side. Here I was squaring the left-hand side to get these three
Yeah,
terms.
but you don't do it to the second part.
I did. It's right here.
So you do it to both sides.
I have to square both
That's what it
sides.
says.
Yeah,
So
we
squaring-
always.
By squaring it, you're using the contract.
Yes,
That's what I was.
because I have to square this. And that's why I wasn't even talking about that
So
side.
that's what the contract was.
Yes, when you square binomial, you have to get three terms. Again, you can write it on the side and foil it. You don't have to use the formula if you don't want to. Okay, what type of equation is this? Good, so then x squared
Right 9x plus 18. X minus 4x
x minus 3 and x minus 6. And there are two options.
3 and 6.
Do you all agree so far with these two options? Are we okay? These may or may not be what we're looking for. So I'm back to the original problem. I plug in 3. 3 minus 2. The square root of 1. 3 minus 1. Does that equal 4? No. Now I'm checking 6. 6 minus 2. 4. The square root of 4. 6 minus 2. Accepted? Yes. Okay. So now we have a bunch of word problems to look at, in which in all of these problems we will apply the Pythagorean theorem. So any questions on this? Any questions on this? Any questions here? Everyone? Okay, perfect. So now, in any right triangle, if we denote, it doesn't matter how you denote the sides, I'm going to say A, B, and C, then the longest side squared must equal the sum of the squares of the measures of the measured squared of the two legs. So, for example, in 53, we have a right triangle. We are told that the hypotenuse is 7 meters. One leg is 3 meters, and we are asked to find the other leg. So can anyone dictate the equation?
3 squared plus x squared.
That's fine. You can write it from this side or from that side. It doesn't matter. Very good. 3 squared plus x squared equals 7 squared, which is 9 plus x squared equals 49. I have to solve for x squared first. 49 minus 9, which is 40. Okay, now let's talk about taking square roots from both sides. Let's talk about that principle. Taking square roots from both sides of an equation. So far, we squared or cubed or taken to the 4th power. Now we want to take the square root from both sides of an equation. Now, one more time, what type of equation is this? Quadratic. How many solutions will a quadratic equation have no matter what? Yes. So I expect, so this is quadratic, and I expect 2 solutions. So careful when I take the square root from the left and square root from the right. Assuming that x can be any real number, how do you, and carefully think for a moment, how would you write this? Assuming that x can be any real number. Wonderful, excellent. Now how do I simplify this? From the previous 4 sections, I know how to simplify it. 4 to the square root of 10, very good. But now I know that this equation will have 2 possibilities, x equals and x equals. I've solved these in chapter 9. What are the 2 options? 4 to the square root of 10 and negative 4 to The square root of 10, of course. Now, which one does not work here? It doesn't have place here.
Negative.
Yes, would you agree?